Welcome back to our series on statistical methods. I'm Mark Ledbetter, and we are in Chapter 2, and I'm going to use this video to introduce RStudio and R Markdown documents, or RMD as they're called. So this file is called an R Markdown document, and so it has an extension of RMD. And we can combine text and code in a very, what we call, say, symbiotic fashion. So we can create a professional report, and we don't have to switch between R and some other word processor like Word or Google Docs or Pages or even LaTeX if you want to use a professional typesetting program. In fact, RMD uses LaTeX, as we'll see later on. But you can take this document and export it to MS Word and then modify it if you like, and then PDF or what have you, or you can take it directly to a PDF or directly to an HTML output. All right, so we run this in chunks. So here is chunk 1, or the first chunk in the document. It starts with these three backslash symbols, and they are the symbol where you'll find this symbol and the tilde symbol, the squiggly line, up beside the 1 key on your keyboard if you're using a regular keyboard. This is not the single quote. Let me show you the single quote. This will not do anything. So we start a chunk by using these three symbols, right? So these three back strokes here. And then we use a curly bracket, and then we have to put R to tell it that we're running R and not Python or anything else, okay? Any other program. Now, everything else is optional. You can put nothing here, and then this will be an unnamed chunk of code, okay? I like to name them. They have to be named uniquely. That's the only problem. If you copy and paste, you need to change the name. I like them to be named uniquely so that if I'm compiling this document and it crashes, it tells me which chunk by name that I had the error in, and then I can go and debug it. All right. So our code runs in chunks, and they start and end with these three symbols here. They're the back, kind of a backslash symbol. I forget what they're called, but you see that we start it with these three and we end it with these three marks, and they're not quotations. And then we have the curly bracket, and then we have R. Oops. So then we have R here, and we end the curly bracket, and then we start running code. We can start running code on the very next line. You cannot run code up here, I don't think, so you don't want to. So we have code here, and then we end it with these three, and then the next, after those three, we're back to text. All right, so you may wonder what this is here. This is saying a new line. That allows us to go to a new line in R. You can put it at the end here so that it goes to a new line. Let me just say that RStudio does not put new lines just because you type it a certain way. There are very specific ways that you can do that. The first is to have 2 spaces at the end of your line, 2 blank spaces, and then hit enter, and that should put what you type next on another line, okay? The other way to do it is backslash new line. You'll notice that it's in blue, right? So that tells you it's a command. And then another thing that I do, sometimes new line won't work for me when it's right before a chunk of code. So before a chunk of code, or right after a chunk of code, new line doesn't do anything. In fact, it may give you an error saying there is no line to end here. So what we can do is vertical space, or V space, and then see if it comes back. There we go. So in the brackets, we put how much in units. You can put inches. I'm using millimeters here because they're a little finer than inches. Otherwise, I have to use decimals and inches most of the time. Okay. So in this first, I'm calling this my global settings. I'm doing a few things. One is I am removing any variables, any and all variables that are in my memory, just in this program. So in this instance of RStudio, I should say. Over here on the right, you'll see environment is empty, global environment. Objects that have values or text, or not text, vectors or scalars or data frames, lists, etc., those will show up here once they have been created. Okay? Now, I want to remind you that just typing something doesn't create it. You have to run the code in order to do something. Just me typing this doesn't remove all the variables. I have to actually run this code. Now, there's a whole bunch of different ways to run the code. So the first is, if I want to run this whole chunk, I come over to this green arrow and it says Run Current Chunk. When I do this, this section down here called my console, you see it says console, also has terminal and jobs, that I can move by up and down. When I run this chunk, it's gonna minimize. It's gonna make this console go minimize. So I'm gonna, when it's done, I will click on where my little hand symbol is to reinstate that console. Okay, so you can see that there's 4 major windows here. The first is your code. The second is your console, where we actually get the results. Then this third over here is our environment, but we can put history, we can put connections. There's a few different things we can do. If you want this bigger, you can resize it. If you want it smaller, you can make it smaller. Okay, you can't always see everything if you make it too small. You can also take it all the way away. All right. And then this fourth screen, you can see files, you can see plots, packages, help, and it's very handy, so you don't have to do a lot of fancy things that you have to do in other programs to get help. All right. So let's run this first chunk. I'm going to run the whole chunk. As I said, this console went away. I'm going to restore it, and that way I can see what's happened. And you see in blue, RM list, there wasn't anything to get rid of, but it tried to delete anything. And then I have these settings. Warning equals false. I don't want it to tell me warnings because those get to be some really messy output, and I want to avoid that. And then message equals false. Again, there's a lot of really messy messages. Now, echo equals false. I'm going to change that to true because I believe, if I remember correctly, that true echo is putting this chunk. Oh, this is saying that I want the chunks or don't want the chunks to show up in code. All right. Now, I can also override these global settings here. And the last one is that the figure align is going to align the figures in the center of the page, and that is a default. You could change it to left or right, I believe, but be careful with that. It may not look good. So I can come up here and put a comma and then say message equals false. Okay? Or I can say echo equals, and maybe I don't need the comma. Let's try it without. Echo, nope, it just doesn't like it in this first one. Yeah, I do want the comma. I can see by looking at another one, so I'll say echo equals false. Okay, and now this little chunk of code itself will not show up when I compile. Okay, it won't show up as code. The options max print equals, what, 10 million or something. This just prints out more lines in my console. Otherwise, when it gets to 1,000 lines, it just stops printing and says you're missing however many lines. That's very frustrating if you're working with large data. So that's the reason I have this preset. Then I have some vertical space so that when I compile this And we won't talk about how to do that in this video. But when I compile this, I want some space in between my chunks of code and my text so that you can easily see it. So that's the reason I put the V space above and below. So again, I've told you here that the name of the chunk can cause issues if you forget to make them unique. They need to be unique or different names for each one. You could change global chunk 2 here if you copied and pasted this. If you made just change one letter in the name and you're good. Okay. And then here I have a chunk called packages. Okay. And I don't want to include this in the output, and I want messages to be false because they put out a whole lot of messages sometimes. So I don't want those to be compiled. And I've listed all the packages you should need in this chapter for everything to work. Now, the key here is if you've never run this before, you may not have this knitter package installed, in which case you'd want to come up, and I'm going to Control Copy and then Control V, and then I'm going to say in here KNITR. Okay. So these pound signs have made this a comment. So if I try to run this, and one of the ways, let me back up. If I want to run just this line of code, I can select it all, or I can just be anywhere on this line and I hit Control Enter, and you'll see that the only thing that it ran down here was this one line of code. You don't have to select it and be precise or anything. Now, if I just want to work to run this, which I don't, that wouldn't make any sense. But if I just want to run one object, I have to select the object. Then I can hit Control and Enter. I think on a Mac it's Command Enter, and it will run just what you have selected if you select something on a particular line. So if you want the whole line, just Control Enter or Command Enter will run that. Well, since I have this commented, I can uncomment this by Control Shift C. And so now it's there. I don't need to because I've already installed this package, so I don't need to run this. I won't because no need to go through that. To comment something or uncomment, you use the same thing. Hold down the Control, then the Shift, then the C button, and it will change it from commented to not commented. Again, anything with a pound sign is in the code is commented, and it won't run that code. So I can run using Command or Control Enter. I can run that one line, then another, and I'm going to go ahead and do all of these since I started them. And so it will go through, and you can see that it's working. There was a little stop sign here that told you that it was thinking. Okay. Now, if you want to see the list of functions in a package, you can type help package, and in this case, reshape. So I'm going to just hit, I'm selecting this code. Even though it's on the same line as a comment, I don't have the comment selected. So what I've selected will run when I hit Control Enter. And so over here in the help, now you can see here are the help pages, and it will list out these. The melt is the function we're going to use, and these other functions that are defined in this package. Okay, so it gives a description, and you can click on that to find more of it, more out about it. Okay. Again, I can run the whole chunk here, current chunk, by running this. I don't need to run it again, so I won't. Now this button now is showing up. Since I'm not in the first chunk, I can now run all chunks above this chunk. Well, there's only one, which is the global settings. Okay, so I won't run that right now. The other way to run code here is to come up to this button here and to say run selected lines, run current chunk, or you can come down and say run all. Be careful with saying run all, because if you have an error in somewhere, then it's going to try to run everything, and you may not be ready for it to. I rarely use that one. I will run things a chunk at a time most of the time, or I will get down to a certain level and say run all the chunks above this chunk, and then when it's done, I can then, if I want to, run the current chunk. And that's an efficient way of doing this. So these packages have different commands and functions that you can use that will be necessary at some point in the course. Okay. So now I have this example that we want to do, and the first step we need to do is input data. Now notice that I've put text BF. That means boldface the text. What's in here is going to show up when I compile this, not today, not in this video. Then it will be boldface step 1 input data. And so I've put a description of the problem that we've gone over in some of the other videos. So the engineers added a polymer latex emulsion during the mixing, and this was to lower the cure time of the mortar. And so this is for mortar. And the problem is he or she is concerned that this emulsion could lower or worsen the tension bond strength. So we need to test for that. And so the engineer ran 10 samples of the original formulation and 10 samples of the modified formulation. And they tested them. And so we consider this to have two treatments or formulations, without the emulsion and with the emulsion. Or you can say it's two levels of a factor called formulations. And so this is terminology we'll use in design of experiments. And again, I've put a 1 millimeter space to make sure that I don't run these sentences on top of each other. And so the experimenter said that they did test this, and they found that the modified mortar was noticeably shorter in cure time, which is a good thing as long as the strength isn't compromised too much. So we need to enter the data, and the best way, if the data is not included in a package in R, because that's the easiest way, you just attach the data. But I'm not going to go over that right now. That's another thing that you can Google and look up. But what I'm doing is I'm calling my data Y1. Since Y is our response variable, I'm going to call it Y1. And I'm making it a matrix to begin with. And C means to concatenate or to group it together. So when I type this in, if I just type C and this to here, oh, by the way, when I get to the right spot with my cursor, do you notice the shading up there besides the letter C? And so our parentheses, that's one way to tell which parenthesis is paired with which other parenthesis. So here down here on the next line, you can see that there's that one. All right, so that's the end of the command. So this is the column. So you can take the data that I'm providing in Excel. In the course, there is a folder called data files. So you can go in and find the correct chapter, and then within that there are tabs for the different, or there's different questions, and you can find the correct question, copy and paste the data right into here over top of this, like select this through here and paste right there. And then you will not have commas, and you'll need to put commas between the columns. Okay, so this first column is the modified. The second column, or this column of numbers, is the unmodified, and this first column is just the identifier, sample 1, sample 2, just the order in which they were produced in each of these. Okay, and so then I have by row equals true. Okay, that means that this is going to fill up a row going from left to right by default. If I said false here, then it would fill up the columns first. It would go down. It would take this and put them vertically down the first column. You usually don't want to do that. Okay. And then I have to tell it how many columns I have. And in this problem, there's 3. One here, one here, and one here. And you'll notice there's commas all the way down beside every number in this row, beside every number in this row, but the last number in the whole thing, there's no comma, because the next thing is this parenthesis, and you don't need a comma before the parenthesis. If you put a comma here, it thinks you're missing a number, and it will give you an error. Okay, so we're saying by row is true, and there's 3 columns. So that means that each line of these is going to remain a row. with 3 columns. Okay. Then I'm saying set the column names of Y1, and this means assign to this these values. And so I have ID in quotations, comma, modified in quotations, comma, unmodified in quotations. And then I'm saying change this from a matrix to a data frame. Okay? So I could set this equal to a data frame to begin with, but it's a little more complex, and it seems to be a little easier for students and me to understand when I do it this way. So I'm going to run this for this whole line of code between here and here. And all I have to do is be anywhere in here and hit Control, and then hold down Control, and then hit Enter. And you notice the green bar showed up. And now you'll see that Y1 is over here. And if I click on Y1, it's going to bring up that object, and it's just saying variable 1, variable 2, variable 3. I didn't name it, so it doesn't know what to do. It just says V1, V2, V3, and then the row number, and then I have the sample number in here that I've given, and the data. Okay, and so it tells you over here that it's numeric. That's important. And this tells you the number of rows, 1 to 10 rows, and there are 10 rows going down, and 1 to 3 columns this way. And then it starts telling you by column, which is interesting. That's R is a little different than other programs. So it populates by column by default. So it's reading that first column of information. And you usually can't see enough over here. So that's why if it's under data, you can click on it and it will open up an instance here. And then I'm going to come up, well, I'm having a little computer problem here. There we go. I'm going to come up to the X and close that. All right. And the other way I can do this is I can just select Y1 now, and I can say Control Enter. Notice down in the console that when I clicked on that, it typed in a command View Y1, and it opened that separate screen up here. Now I'm going to select Y1, only Y1, hit Control, then Enter, and now it's going to print it out. And so I haven't assigned column names yet, so it's saying it's making this a matrix. Row 1, comma, and then the columns. This is column 1, so row goes first, then column in the numbering here within the brackets. Okay, so 1, 1 would be right here. 1, 2 would be here. 1, 3 would be here. The row comes first, then the column. Okay. Now it also printed it out in the document right here. So it printed out in the document. So when we compile this, this would show up. If we have a command to print this, this would show up in our final document. I don't have that command, as you'll see. So the next thing I'm going to do is run the column names, and then I'm going to change it to a data frame. Before I do that, I can still just select Y1 and Control Enter, and now you see I have the ID modified, unmodified. So it's changed the column names to what I set here. Okay, so when you change your data for your problem and it has more or less columns, change the number of columns, and then you need to change the column names to match what the data is. And that needs, I have 3 names here and there's 3 columns, so you need to make sure those match up. Okay? And then the next thing I'm going to do is make it a data frame, and this just makes it easier to manipulate. But now when it prints out like this, and it puts it, you see how you have a white, gray, so it stripes it. All right. Now, I have also put in code in here to make this a nice table that you can put into Word or what have you, so it really makes it nice. So this is how I'm printing it out. So, so there is a nice table. If you want to copy this and put it into a document, I suggest you come over to the viewer here on the right click, select all, right click, copy, and then you can go and paste it into Word or Excel, and it works great that way. All right. So that's getting the data in, and that is usually the hardest part in programming. one of the hardest parts is to get the data in the right format. Okay. Now, we want to do some descriptive statistics, and I've showed you this in the videos that I've posted in the class. So there's two ways that we're going to look at descriptive statistics. The first is using FabStats, and that's from the Mosaic package. And the second is the Describe By from the Cite package. Okay. So the first thing that I could do is, without doing anything to my data, all I can do is one column at a time, I believe. So FabStats unmodified, or modified, and then here's FabStats modified. Okay, now if I run the whole chunk, look at what happens. First, I'm going to get my console back. I have two things I can click on. The first is the first command that was run, the first output, modified. And then here is the unmodified. Notice that there's really no label for you to know which one, so you have to look at the order in which it was done. All right, so here's our min, Q1, median, Q3, max, mean, standard deviation, n, and the number missing, 0. And then here's for the unmodified. We can put all of them in one table, but we need to use something called the melt function from the Reshape2 package. And so when it does this, it's going to take what you tell it. So I'm telling it to melt Y1, and I'm saying only do columns 2 and 3, because column 1 just has my ID number, and I don't need that for anything. It's going to give me a row number, so I really don't need it. So I'm saying melt Y1. If there are NAs, NA is how R treats missing values. It says NA, not available. So it will change it to an NA instead of just blank. It puts something in there. So this says NA.remove, and that is true. That means that if anything's an NA, then I get rid of it. So be careful, this can cause some problems, okay? So if it doesn't work with true, set it to false and try it there. Now, value name is the name that I'm going to give the values that are in here, okay? So I'm going to call that strength for tension bond strength, because that's what these values are. They're tension bond strength in kilogram force per centimeter squared. Okay, so kgf per centimeter squared. Okay. Well, when I do that, so I'm going to run just that one line of code. No ID variables were used or were specified, so using all measure variables. All right, so now when I print this, I get note, it just calls it variable. And what I specified is strength. So now I'm going to specify the column names. I've already said it was strength. I could just leave this blank here. I don't have to include this statement. I could get rid of the comma, all of that, and just run it. But this let me, well, there's no trouble with putting, you have text over here and you have the values here. All right. So what this did was it stacked them. Here's all the unmodified, here's all the modified. Modified was the first column, unmodified was the second column. It has now stacked them all on one top of each other and given the column name or the variable name as the identifier for the row now. Okay, and so we're going to say that that's the treatment and then keep the same name. So when I do column names here and then run Y0, now that I've done that, now I get treatment and strength and the values. Okay. Now I can print this out as a, now that I have this, I can run FabStats and I changed the way that I do this. I'm going to uncomment this. And so if I run this, I have strength by treatment. This is like an equation. Strength is my Y and treatment is my category. And then I have to tell it what data frame if I do that. Otherwise, I can say Y0 $, but who wants to do that all the time, especially if you have a lot of these, okay? Which sometimes we have a whole bunch, so we don't want to have to type that over and over. Let's just run this one line and see what we get now. Now we get together modified and unmodified in the same table, right? So all of the descriptive statistics we want for both of them at once. Okay, so this is fine. You can use that, but I've given you code so that it actually puts it in the table here. So let's run this, and here is just the Y1, the table itself for the data. Okay, and you'll notice that it shows all 20 rows now. All right. Now I've also given you to put it in a nice table with FabStats. That statement, I've put it inside the table. I hope you'll look at how this is constructed and see if you can figure it out. So, oops, I just ran that. Now I need to unselect and run the whole thing. And now it gives me a nice table and it puts it over in the viewer. And so I could print this out. It will look very nice and professional. Okay. Now the describe by function will only work with the reformatted data. So we have to melt it in order to get this to work. So first I'm going to uncomment and just run the describe by. Notice that here I have to say, I don't have a place where I can specify what data. So I have to put the data frame and then $ and the name of the variable. Then I have to tell it the group. This function is very finicky. It has to have a group. If you leave out the group, it won't run. So I had to tell it the treatment. And then mat equals true says that we want it to be in a matrix format. So if I run this, it puts it in a matrix format and it tells me a lot of things. Now look at this little arrow here. So I need to click on the arrow to get to the rest of the values, and then I can click backwards to get back to this. Okay. So then if I run it as cable, so I'm going to comment this back, then I can run it using the cable, which is like a certain table, and I've embedded this statement inside the table, so it runs this and then formats it and names it. So here is the table with this information. Okay, and the problem is that it cuts it off, but it doesn't over here in the viewer. Okay, so it's not cutting it off in the viewer, but it is cutting it off in the document. So that is an issue. All right. Now, I've put text bold space, graphical analysis. Now histograms. Oops. So histograms, we have 2 treatments, and we want to look at the histogram of each. So I have this parameter thing that says I want for one row of pictures or items, and on that one row I want 2 items each. So it allows 1 row and 2 graphs before it changes to a new object. And then I have hist, which is the histogram function, and I'm doing the modified. I'm saying frequency is equal to true, so I get a histogram and not a density plot. If I say false, I get a density plot. Main is the main title. Xlim are the limits for the X values, so the min and max values I want it to print out. Ylim is the min and max values, so 0 to 3.5 for the Y values. And what I did was I printed out the data without these, and then I said, yeah, okay, let's standardize this between the 2 groups. I want the same scale on both. Okay, and then in class is the number of bars. This is just a suggestion. R ignores it in a lot of ways, but it'll try to get as close as possible. There is a way to force it to 5, but you have to write out each boundary value in something called breaks. So you have to put in the tedious statement of each of the breakpoints you want for between the classes. And then X label, that's what X lab stands for. And so this is going to be the label for the X value. So if I run this and this, now when I run it just one at a time, it doesn't always show up the way you want it to. But here I've actually got 7 bars. 1, 2, the empty one, 3, 4, 5, 6. I'm sorry, 6. I can't count. But you see tension bond strength down at the bottom. You see frequency on the side, and then the name at the top. And then we did the unmodified in the same way. So And then we have a statement to take it back to one-to-one, one row, one column for each, so one graph per plot. Okay, I'm going to run this whole chunk so you can see what it looks like. So it's putting these side by side so you can compare them now. So I only got 4 bars over here. I got 6 bars over here. One of them is empty. But I can see how they're distributed now because they're on the same scales, both X and Y. Okay. A strip chart uses the melted data frame, and we use a function called a dot plot. And so again, I've done strength by treatment, and then I've put in the Y limits. Again, that's an optional thing. And then I had to specify which data. Anytime you want to know about one of these functions, come over here and up in the top. So up here in the very top, type in dot plot, and this does not have a capital P. See, the first one has a capital P. One I'm using does not. Click the right one, and I think it's still thinking. It hasn't. Yeah, here we go. So then it pulls up all the possibilities, and I know that I'm using this from the basic graphics. So so graphics somewhere down through here will be dot plot, ggplot, survey. So graphics dot chart, but that's dot chart. I wanted dot plot, and I'm probably just not seeing it. Here's mosaic dot plot. Here's a lattice panel dot plot. So sometimes it's hard to find the one you want. But you can also go to Google and type it in and find out something about this. All right, so here it gives modified by dots here, unmodified here. And by default, it's going to be on the same scale because they're together, okay? So that helps you compare, and you can see the shift between the modified versus the unmodified are shifted higher, or the modified are shifted lower. The last graphical method is called the box plot. And so so I have this function box plot, and I'm doing strength by treatment again, and I'm calling my data frame Y0. Main, that's the main title. Box plot of the tension of the bond spread. Here's my X label. And then Y label, I'm putting it empty. I did this because I didn't like where it was printing out my Y label. And so I did a search on Google, and it said make Y label blank, and then come back and use the title function for the Y label. And you can use line number to tell it how far above the axis here, how many lines. This is the first line, then this is, and somewhere around here would be the second line. I said 2.5 lines, okay? So if I change this, watch what happens when I change this to 0. So I'm gonna run this whole chunk. I change this to 0, it sets it right on the y-axis. I change it to 1, and it moves it right on top of the labels. I change it to 2, and it's just right above. You may like this. I decided to go to 2.5. Let's see. Let's see if I can keep it in the frame while I do this and see if it moves. See it, so it moved a little bit further away. The default was 3, and it was just almost cutting off. It was actually cutting off the square here on my centimeters. I'm using LaTeX, a function in LaTeX, to make this the square turn out the way I want it to as a superscript. And so I put this all in quotations, and then this caret here means square or superscript in this case, okay? So there's my code to give us nice box plots of the modified and the unmodified on the same plot, and that's important for comparison methods. Okay, that's it for this lecture. I know it's been long, but I hope it's been informative, so please take care of yourself, and we hope to see you next time.